It's really easy to think of engineers simply as the people who apply physics to build bridges or write code. But when you really dive into this topic, it's fascinating to realize that the most impactful engineers out there are actually deep in the trenches of research. They aren't just using the tools, they're literally inventing them. Let's explore this engine of progress. Which brings up a pretty provocative question right off the bat. Why should a highly practical, hands-on engineer even care about abstract academic research? I mean, it's tempting to assume research is just for scientists in white coats, completely removed from the dirt and grind of the real world. But, as we're going to see, research is the vital puzzle piece. It's the literal bridge that connects abstract theory to the tangible, everyday solutions that engineers build. Whether it's designing smart cities or creating energy-efficient homes, research is what takes a theoretical what-if and turns it into a highly practical, here is how. Okay, here's our roadmap for this explainer. We're going to cover 1. What is R&D? 2. Types of engineering research. 3. Academia versus industry. 4. Fueling innovation with grants. And finally, 5. The future of engineering. Let's jump in. Section 1. What is R&D? Defining the core of innovation. It turns out separating these two terms is absolutely crucial. Research is the hunt for entirely new knowledge. It's asking the questions no one has answered yet. Development, on the other hand, takes that newly discovered knowledge and applies it to actually build or improve real-world technologies. Together, they are the absolute backbone of economic growth. Moving on to Section 2, Types of Engineering Research, the Sequence of Innovation. It's kind of amazing to see how an idea evolves across this timeline. First, you have basic research, which is all about expanding fundamental knowledge, like, say, discovering a brand new lightweight material in a lab. Next, applied research steps in to use that material to solve a very specific problem, like reducing the weight of an electric car. And finally, developmental research does the gritty work of converting that into a physical, working prototype that's actually ready for the market. Section 3, Academia versus Industry. Two distinct environments. So there is a stark contrast in where all this innovation actually happens. On one side, you've got the highly focused, intensely detailed university lab environment. And on the other, you have the scaled-up, precise manufacturing floor of private industry. One is essentially looking through a microscope to find the truth. The other is optimizing a process to serve a massive market. Breaking that down a bit further, academia's core objectives are knowledge creation and training the next generation of thinkers. It's really about building national capacity from the ground up. Industry R&D, well, it plays by entirely different rules. It is strictly driven by the market, investing heavily to gain a real competitive advantage over rival companies. All right, Section 4, Fueling Innovation with Grants. This is the financial engine. Grants are the absolute lifeblood of this entire ecosystem. Let's be real for a second. Innovation is incredibly expensive. You can't just have a eureka moment in the shower and call it a day. You need serious capital for high-tech infrastructure, hiring expert personnel, running complex fieldwork, and ultimately publishing those results to the global community. This funding basically falls into two main buckets. First, you have government grants. These focus on long-term public interest, things like national security or tackling climate change, and they result in broad knowledge and policy. Private grants, however, demand tangible commercial value. They are usually shorter, highly flexible, and they absolutely expect real products or services at the end of the line. To put this into perspective with a localized example from our source material, let's look at Bangladesh. Engineers there can tap into massive national funds through groups like the Ministry of Science and Technology, the ICT Division's Innovation Fund, the UGC, and the BCSIR. This allows them to align their cutting-edge research directly with strategic national priorities. But hey, securing the bag means taking on some serious responsibility. In the research world, you aren't just a tinkerer. You are a steward of funds. You have to systematically identify a genuine problem, write a convincing proposal, manage the project with absolute ethical integrity, and ultimately, you've got to deliver the measurable outcomes you promised. Finally, Section 5, The Future of Engineering, Navigating Tomorrow's Challenges. Look, it's a demanding path. Today's researchers are constantly battling constraints. They're fighting for limited funding, navigating a lack of infrastructure, and trying to bridge that frustrating gap between the slow pace of academia and the rapid-fire demands of industry. Add in the intense pressure to publish or perish, and time management becomes a massive, massive hurdle. But despite those hurdles, the path forward is genuinely exciting. The future belongs to those who break out of their silos to embrace interdisciplinary research. It's about harnessing AI and data to solve incredibly complex problems and aligning our engineering goals tightly with global sustainable development and cross-border partnerships.
Moving forward, technology and humanity simply have to work in tandem. It's not about machines replacing human ingenuity. No way. It's about ethical, forward-thinking research where engineers use advanced tech to elevate the human condition responsibly.
I want to leave you with this amazing thought from Professor Hashem. He notes that an engineer who doesn't engage with research applies yesterday's solutions to tomorrow's problems, while one with a research mindset shapes the future responsibly. So as we close this explainer, ask yourself, are the tools and methods you're learning today genuinely preparing you for the unknown problems of tomorrow? Or are you just mastering the past?